outer space extends so infinitely far that it is impossible for the human perception to appreciate its vastness. In this eternal abyss, permeated by electromagnetic pulses and streams of interstellar gas, there are objects whose nature defies our current understanding of physics and astronomy. Let us embark on a fantastic journey to the least explored and most mysterious places of the universe and get acquainted with the most unusual space objects. Our journey will begin at the edge of the solar system, near the enigmatic Pluto, which still holds many secrets and mysteries. Then, having traveled tens of light years in the blink of an eye, we will whiz around the most unusual exoplanets that defy our ideas about the laws of nature. And after that, we will meet a unique and mysterious double pulsar that distorts time and space around it. As we pierce the interstellar vacuum, we will travel to mysterious black holes lurking in the darkness of the universe, and then leave the Milky Way to go to the most unusual galaxies. Finally, we will plunge into the fathomless depths of the intergalactic majestic voids, the keepers of the secrets of the birth of the universe. Let's get ready, and we begin.
Kosmo.
Pluto is about 40 astronomical units away from the Sun, and is a dark and indistinguishable object. This distant celestial body follows a rather elongated orbit around the center of the solar system, completing it every 248 Earth years. We know that Pluto's radius is 1,188 kilometers, which means that it is noticeably inferior in size not only to all the planets of the solar system, but also to some of their satellites, including the Moon. At the same time, observations of the celestial body's proper motion made it possible to calculate its mass with a high degree of accuracy. It turned out to be small, only 1.3 times 10 to the power of 22 kilograms, or 18% of the lunar mass. It is easy to see that Pluto is much more similar to small celestial bodies such as Eris, Ceres or Sedna in terms of its characteristics. This is the reason why it topped the list of dwarf planets in 2006. Due to its long and elongated trajectory, Pluto has a long orbital cycle. Only in 1989 did the planetoid first pass its orbit perihelion since its discovery, approaching the Sun as close as 29.7 astronomical units. Since then, this distance has been continuously increasing and will reach its greatest value in the year 2113. By that time, the dwarf planet will be near its aphelion, which is 49.3 astronomical units away from the center of our system. Thus, Pluto is a very distant and dim space object. That is the reason why it cannot be seen from Earth with the naked eye. And even in images from the Hubble Space Telescope, the dwarf planet looks like a murky brown disk without any surface details. Of course, in such conditions, it is almost impossible to study the celestial body properly. To solve this problem, the New Horizons Unmanned Orbital Station was sent to Pluto in 2006. It took a long 9.5 years to reach its destination. On its way, it beamed back to us detailed images of Jupiter. It wasn't until 2015 that the spacecraft finally reached the main object of its mission. As it flew past Pluto, the station made about 400 observations, collecting more than 6 gigabytes of information, and it took more than a year to transmit this large amount of data to Earth. Unfortunately, the probe's trajectory did not allow photographing the entire surface of the dwarf planet. The fact is that New Horizons did not enter into an orbit around Pluto, but circled round Pluto in order to be able to explore other space objects. Before moving on to the celestial body's terrain features, we need to understand its internal structure. According to the currently accepted model, Pluto has a massive core with a diameter of about 1,700 kilometers, consisting of a mixture of various forms of water ice and rocks in its center. It is surrounded by a 300-kilometer ice mantle. There are probably tectonic processes running in the mantle, and in the moment they are quite understudied. The mantle, in its turn, is covered by a crust, which is a mixture of crystallized gases such as nitrogen, methane and carbon monoxide. According to some assumptions, Pluto's core may generate enough heat to melt some of the icy mantle. In this case, deep beneath the surface of the planetoid, there should hide a very salty and toxic ocean containing large amounts of dissolved ammonia. As for the surface temperature of the dwarf planet, it is very low and is not over 60 Kelvin or 213 degrees Celsius below zero. Our journey around Pluto will start at the most outstanding and well-studied feature of its relief, Tombaugh Regio. This vast area is located in the equatorial zone of the planetoid and is shaped like a heart sketch. This resemblance earned the region its informal nickname, the Heart. Its size reaches 2,300 kilometers, which means that the plane occupies about a quarter of the celestial body's entire area. Tombaugh Regio's surface is not homogeneous. Thus, there is a smooth and light plain in its western part, known as Sputnik Planitia, whose diameter measures 1,492 kilometers. An elevation map will reveal this region to be a vast lowland area. It is covered with a thick layer of nitrogen ice, as well as carbon monoxide and solid methane. These substances have a light coloring, which makes some parts of the plane reflect up to 90% of the light falling on them. There are also virtually no craters, which means that the region is very young in geological terms. According to the main hypothesis, Sputnik Planitia formed about 100 million years ago, when Pluto experienced a collision with a large celestial body. As a result, a huge impact crater appeared. It was filled with contents of the hypothetical inner ocean of the dwarf planet, which rapidly froze there. Some typical features of the relief of the plane can serve as evidence of this. For example, there are quite a number of smooth surface areas on it, ranging from 20 to 30 kilometers in size, with hills and depressions concentrated on the borders between them. This kind of structure resembles convection cells, which appear in any fluid heated from below. This may serve as an indirect confirmation of the hypothesis of Pluto's warm interior. Tombaugh Regio is surrounded by comparatively high mountain ridges. Thus, Hilary Montes, lying to the west from Sputnik Planitia, reach 3.5 kilometers in height. Tenzing Montes are located in the southern part of the heart. Some of them tower as high as over 6 kilometers above the dwarf planet's average surface level, which makes this ridge the tallest one found on Pluto. Remarkably, these rocks are likely to be made up mostly of water ice. And in temperatures as low as here on Pluto, water ice is as solid as rock. Moving a little further south, we can see a deep basin surrounded by massive multi-layered ridges of ice and rock. It is assumed that it may be the vent of an ancient cryovolcano, and the rock around it is its numerous frozen eruptions. Their chemical composition is of great interest to science, because once it is known, the peculiarities of Pluto's inner makeup may be studied. The eastern part of Tombaugh Regio is darker. In addition, its surface is pockmarked with a great number of craters, which means that this region is by far older than Sputnik Planitia. Moving further east along the equator, we will see a chain of dark spots, hundreds of kilometers in diameter. These objects are called maculas and are named after dark deities of various cultures. For example, one of them is named Balrog. Together they form a giant structure called the brass knuckles, encompassing the celestial body along the equator. The maculas are separated by high mountain ranges, and their surface is cut by deep crevices reaching hundreds of kilometers in length. Cthulhu Macula stretches to the west from Tombaugh Regio. It is the largest dark spot on Pluto, measuring almost 3,000 kilometers. its surface reflects not more than 30% of the light shed on it, which is a stark contrast with the bright and light Sputnik Planitia close by. There is still no reliable information about what maculas are. It is assumed that their dark color is due to a high content of tholins, combined with a relatively large concentration of impact craters. This indicates that maculas are remarkably old. It is also known that the surface of Cthulhu Macula is heterogeneous. Thus, its relief in the western part is undulating. The central part is a smooth plain, and the eastern part is covered with mountains and craters. Leaving the grim spot of Cthulhu Macula behind us, let's head north. Here lies Lowell Regio, the vast valley surrounding Pluto's North Pole. Surprisingly, it is this place that is currently the most illuminated part of the celestial body's surface. The point is that Pluto's axis of rotation has a very large tilt with respect to the plane of its orbit, so in its movement it found itself facing the Sun with its North Pole. It is assumed that it's for this reason that the density of Pluto's atmosphere has tripled over the past 30 years, despite the growing distance from the Sun. It is likely that the Sun's rays evaporate nitrogen ice settled at the pole, which goes into the dwarf planet's atmosphere. In its orbital motion, Pluto has a number of peculiarities compared to the planets of the solar system. In addition to the fact that its orbit has a noticeable tilt to the ecliptic plane, the planetoid itself constantly performs cyclic oscillations near a certain point. This is due to the presence of a large satellite, gravitationally affecting the dwarf planet. It is called Charon, and its mass is 1.52 times 10 to the power of 21 kilograms, which is more than 11% the mass of Pluto itself. As a consequence, both celestial bodies orbit a common mass center between them. They are tidally locked to each other, so they face each other with the same sides at all times. Unlike Pluto's, the surface of its satellite is noticeably darker and shows an abundance of water ice, which is mixed with methane and nitrogen only in some regions. In addition to Charon, there are several other satellites, but all of them are much smaller and irregular in shape. Nix and Hydra, discovered in 2005, measure several tens of kilometers, and Kerberos and Styx, which were discovered later, are not over 16 kilometers in diameter. All of these celestial bodies consist mainly of water ice and were probably captured by Pluto's gravity from the Kuiper Belt. Unfortunately, a significant part of Charon was not caught in the field of view of the New Horizons probe's cameras, but many curious terrain features can be found on the visible surface of the celestial body. For example, to the south of the equator, there lies a vast region called Vulcan Planum. Its area is not known precisely, but it is not less than 400,000 square kilometers, which is comparable with the size of an average European country. Here, the highest summit of Charon can be found, Kubrick Mons. Its diameter measures around 40 kilometers, and according to some estimates, its height reaches 4,000 meters. In addition, the mountain is surrounded by a wide circular moat, as it were, up to 2 kilometers deep. According to some assumptions, Kubrick Mons may in fact be a cryovolcano. In this case, it is very likely that the area around it has sunk under its own weight due to the emptying of the underground reservoir. To the north stretches the vast Oz Terra, the surface of which is pockmarked with many craters. It is separated from Vulcan Planum by a system of giant ledges and crevices with a total height of about a kilometer. The largest of them is Serenity Chasma, which is 200 kilometers long with a width varying from 40 to 50 kilometers. It can be as deep as 7 kilometers, and it is difficult to explore its bottom because of the thick shadows cast by the steep slopes. Further north yet, near the very pole, there is the giant Mordor Macula. Its diameter reaches 475 kilometers, and its origin is still debatable. According to the dominant hypothesis today, nitrogen and methane floating from Pluto's atmosphere were trapped by Charon's gravity and so settled at its poles. After exposure to ultraviolet radiation, they turned into tholins and gradually concentrated in the ice of the celestial body. This assumption needs verification, which will be an object of future missions. Charon largely remains a mystery to us because its research is only just starting. Although the Pluto-Charon system is undoubtedly one of the most interesting structures in the solar system, it is still understudied. Unfortunately, the New Horizons probe left its environs long ago, and the celestial bodies themselves are rapidly moving away from us, taking their secrets along. At the moment, the probe is more than 50 astronomical units away from the Earth, and from time to time beams back to us some extremely important data. By about 2030, all of its systems will eventually fail, and the probe will be left all alone in the chilling recesses of space. As a rule, it's potentially habitable planets with favorable conditions and a moderate climate that especially catch one's attention among the great diversity of other worlds out there, or else, on the contrary, extremely dangerous objects stand out among others. Still, there is yet a third category. It's anomalous celestial objects manifesting unusual behavior which is barely scientifically accountable. Objects like that challenge our knowledge and deserve special attention. This is exactly the kind of world we'll be looking at now. The year 2009. The environs of the Kepler 413 system. An unknown object passes between our planet and a distant star, briefly reducing its luminosity. Astronomers take this event to be a standard exoplanet transit and announce the discovery of a new celestial body. High-precision calculations even make it possible to determine its parameters. The planet turns out to be a cool giant, with a mass of about 25 times that of the Earth and a radius of about 40% that of Jupiter. However, 180 days later, another expected transit never occurred. The planet, so clearly visible in the old data, seemed to have vanished without a trace. A dark spot in the photosphere of the star, or a giant dust cloud moving in its vicinity, would have accounted for the mysterious phenomenon. But these hypotheses were dispelled when 800 days later the mysterious object reappeared just as suddenly as it had vanished. The hypothetical planet eclipsed the disk of its parent star 5 times before disappearing again. Still, the key to the riddle had been found. It turned out that Kepler 413b has a highly unusual orbit. The celestial body is located near a binary star and is 0.36 astronomical units from the system's common mass center. Its trajectory is constantly affected by gravitational perturbations, and the change in gravitation of 2 nearby stars shifts the orbital plane considerably, causing cyclic oscillations. When the deviation reaches its maximum, the object leaves the line of vision and then returns to it. Calculations show that Kepler 413b's orbit oscillates with a periodicity of about 11 years, deviating 2.5 degrees in each direction from its average value. The planet's own axis of rotation also changes its position significantly, with a maximum angle of inclination of up to 30 degrees. Combined with a notable eccentricity of the orbit and its periodic shift, the climatic conditions on the surface change in a bizarre way. The region that receives the most light from the parent star is constantly shifting from the equator to the poles and back, which leads to dramatic variations in temperature. It is likely that this process generates huge planetary-scale hurricanes, which can be larger than the Great Red Spot of Jupiter. Air currents can carry ice clouds at several kilometers per second, gradually becoming unstable and dispersing. Meanwhile, the collision and deformation of vortices is capable of causing tremendous atmospheric emissions that have the power to overcome the planet's gravity and reach outer space. According to calculations, they will hang a while up there before gravitational forces pull them back down. All these incredible phenomena make the planet a rather harsh place. However, it may seem like a tranquil, serene island in comparison to the following world. "190 light-years from Earth. The environs of the HD 10606 system. This yellow dwarf, surprisingly similar in parameters to the Sun, is orbited by a planet with a highly variable climate. It whizzes towards its parent star as rapidly as a giant comet, burning itself in the hot rays of its corona, only to retreat to the periphery of the system. The object is a gas giant, with a mass 4 times that of Jupiter, and a radius slightly different from that of Jupiter. At the furthest point in its orbit, the planet is 0.88 astronomical units away from the parent star, and receives about as much heat from it as the Earth does from the Sun. It has been suggested that this is when clouds consisting of water vapor droplets, ice crystals, or even microparticles of quartz may condense in its atmosphere, and temperatures on the surface of the hypothetical satellites of the gas giant could be comparable to those on Earth. But as the planet gets closer to the star, conditions on it change very quickly. Within 55 days, the distance between them shrinks by a factor of nearly 30, and the energy flux from the star increases by a factor of 800. Observations show that at the lowest point in its orbit, the exoplanet's temperature roughly doubles within a matter of just 6 hours, from 500 to 1200 degrees Celsius. Such drastic changes result in violent hurricanes, which can reach speeds of up to 5 kilometers per second. By absorbing an incredible amount of heat, the atmosphere of the gas giant expands so fast that it produces shock waves capable of sweeping across the entire planet multiple times. Water vapor is broken down into oxygen and hydrogen by the temperature, and quartz crystals evaporate without a trace, only to recondense into gigantic sand clouds later. In all likelihood, HD 80606b is the only planet in its system. The gravity of another nearby star has not only warped its orbit, but has also wreaked havoc on the protoplanetary disk. So the chances of encountering other large objects nearby are rather slim. However, destabilization of a planetary system due to the interaction of celestial bodies is not uncommon. "1,530 light-years from Earth. The environs of the Kepler-36 system. The central object in this system is a yellow subgiant. Its mass is comparable to that of the Sun, and its radius is 62% larger than that of our star. There are 2 planets rapidly orbiting the star, a rocky super-Earth and a hot mini-Neptune. Every 97 days, they mutually approach at a critical distance of only 1.9 million kilometers, about 20 times less than the minimum distance between the Earth and Venus. At such moments, their mutual attraction causes global cataclysms, but after a few days, the celestial bodies diverge again until the next resonance. According to calculations, the gravitational interaction between the planets at the point of closest approach is about 13 times higher than that between the Earth and the Moon. In particular, this effect should be seen on the surface of the rocky planet. Under the influence of titanic forces, its crust may crack and shift, causing earthquakes of incredible power. The resulting chasms may be hundreds of kilometers long and cause multiple eruptions of gigantic volcanoes. It is likely that some regions of the planet do not cool down in the short period of relative tranquility, creating seas of eternally bubbling, red-hot magma. The reasons for the formation of such an unusual system are still debatable. We now know that the super-Earth, dubbed Kepler-36b, is 0.12 astronomical units away from its parent star, and it takes 14 days to complete a full orbit around it. The super-Earth's mass is 3.8 times that of the Earth, and its radius is 1.5 times that of our planet. The object has been calculated to have a temperature of 980 Kelvin, or just over 700 degrees Celsius, and an average density of about 30% higher than that of the Earth. The data suggests that the celestial body could be a Chthonian planet, the core of a gas giant that has lost its atmosphere. Such objects contain many heavy metals like iron and lead, as well as sulfur and silicon compounds. It is likely that the light elements that once made up the thick, dense shell of the celestial body may have been blown into space by stellar wind. Nor should we forget the second planet's gravitational pull, which could potentially have contributed to this process. The object is called Kepler-36c and is likely to fall into the class of hot mini-Neptunes. The celestial body moves in a nearly circular orbit with a radius of 0.13 astronomical units and completes it every 16 days. Its mass is 7 times that of our planet, and its radius is 3.7 times that of the Earth. Because of its proximity to the star, the temperature of the object is also very high, 928 Kelvin, or 655 degrees Celsius. This celestial body should be surrounded by a thick, multi-layered atmosphere consisting mainly of nitrogen, hydrogen and helium. Deeper down, the pressure inside the gas shell increases and it gradually turns into an ocean of supercritical fluid surrounding the solid core. Meanwhile, under certain conditions, truly fantastic phenomena are also possible. For example, the gravity of a more massive planet can potentially capture satellites from its smaller companion, while tidal forces may destroy them to form vast asteroid streams. In addition, the mutual gravitational pull of the two planets distorts their orbits, altering eccentricity and other parameters. Because of this, the entire system behaves chaotically and unpredictably, and its evolution cannot be predicted over any extended period. Modeling shows a 91% probability that the two planets will collide with each other over the next 70 million years, producing hundreds of thousands of pieces of debris which will disperse throughout the planetary system, thereby creating a still greater chaos within it. Such tremendous cataclysms may have occurred more than once in the following system. 434 light-years from Earth. A surprising object, informally called Super Saturn, is located 4 astronomical units away from a young Sun-like star. It is a brown dwarf, or a large gas giant, 20 times as heavy as Jupiter. Observations show it to be a young planet, about 15 to 16 million years old, which is still forming. Most of its atmosphere consists of hydrogen and helium, with a massive metallic core in its depths. This object is spun by a system of rings, like Saturn's but much larger. The transit method revealed at least 37 distinct rings, with the largest one's outer radius measuring about 0.6 astronomical units. This is comparable to the size of Venus's orbit, and about 640 times the radius of Saturn's rings. According to calculations, the total mass of the circumplanetary disk is bigger than the mass of the Earth, and its behavior manifests signs of randomness. Mathematical modeling shows that such structures are not stable and gradually disintegrate. Some of the objects making them up lose velocity and fall to the central planet, while others, on the contrary, accelerate and leave the disk forever. However, this process is greatly extended in time and may take several 100 million years. Also, a large rupture with a radius of about 0.4 astronomical units was detected in the system of rings, which is considered indirect evidence of the existence of an exosatellite in this region, about 80% the mass of the Earth. According to current understanding of the physics of space objects, it is a kind of object capable of clearing its orbit of small debris, forming a wide rupture in the ring structure. In addition, Observations suggest the presence of at least 2 more celestial bodies, with a mass of each of about 30% that of the Earth, and located at a distance of about 0.25 astronomical units from the center of the brown dwarf. Just like it is the case with the large planets known to us, it can be assumed that a total of several hundred exosatellites, including rather massive ones, may be located within the gravitational influence of the central object. A simulation of such a system, including radiation from a parent star, heat flow from a giant planet, and tidal influences, shows that the temperature of the celestial bodies making it up could approach comfortable values. One can only imagine how enchanting the night sky would be from the surface of such an exosatellite. At this distance, the brown dwarf occupies 70 times as much space in the sky as the full moon, and its soft glow can dispel the darkness and turn the night into a misty twilight. Instead of the star-spangled canopy, the planet's sky is crisscrossed by vast swathes of light from horizon to horizon. At the same time, the tidal forces of a nearby massive body could provoke multiple eruptions on the satellite's surface, and its hypothetical ocean could slam the land with giant waves. The width of a tidal zone under such conditions could reach hundreds of kilometers, making it a unique climatic zone, something like a cross between land and the ocean floor. Still, it should be mentioned that such structures tend to be unstable and change their appearance quite quickly beyond recognition. It is difficult to say how much longer we'll be able to admire the giant rings and what they will look like in millions of years. July 1967. A series of pulses was detected with the help of a radio telescope at Cambridge University by a postgraduate Jocelyn Bell. They emanated from a pulsar as yet unknown at the time, and the results of the observations were kept secret for several months. The object was initially designated LGM-1, which stood for Little Green Men. The name was given following the assumption that these perfectly regular pulses were not a natural phenomenon but signals of artificial origin, supposedly transmitted by an alien civilization. Besides, the team of scientists under Jocelyn Bell discovered 3 other sources of similar signals. The phenomenon took 7 years to investigate, and the thesis advisor of Jocelyn Bell's team was later awarded the Nobel Prize for studying this celestial body, which was subsequently dubbed Pulsar B1919+21. This pulsar was the first registered phenomenon of its kind. Its source was to be discovered several years later in the constellation Vulpecula, or Little Fox, 2,283 light-years from the Earth. Information about Pulsar B1919+21 was made public in February 1968, and by 1969 the number of detected pulses of this kind reached 27, and the term pulsar was coined as the official name for these objects. The first discovered source of this signal was the object dubbed PO943. It was spotted by Soviet astronomers in the Leo constellation. One of the most widespread assumptions at the time regarding this discovery was that all pulsars were in fact ultra-powerful radio beacons of extraterrestrial civilizations, and the pulsating signals remind one of a lighthouse twinkling in the night. However, it wasn't long before astronomers agreed that the regular signals were most likely emanated by neutron stars. Today, it is posited that these impulses originate as a result of a neutron star's spinning, and are in fact thin beams of radio waves. They are detected by the observer at precise regular intervals, which accounts for the pulsed appearance of this emission. Approximately 1,790 pulsars had been discovered by 2008. All of them were powerful sources of impulse radio emissions in space. As for the pulsars closest to us, they are located several dozen light-years away from the Sun. After pulsars were first detected, other pulsating sources of similar nature were registered by astronomers. They were described as powerful flares of regular intermittent X-ray emissions. Thus they got their name, X-ray pulsars. X-ray pulsars are also highly magnetized neutron stars, but unlike radio pulsars, which use their own rotational energy, X-ray pulsars are powered by accretion disks. An accretion disk is formed from material captured from the companion star, with the latter eventually becoming a white dwarf with all of its resources depleted. Thus, the mass and spin rate of X-ray pulsars gradually build up during the course of their revolution. As for radio pulsars, they on the contrary slow down as time goes by. For example, the average radio pulsar completes one rotation within the period from several seconds to several tenths of a second, with X-ray pulsars completing hundreds of rotations within the same time period. One of celestial bodies of this kind was discovered quite recently, and it is located rather close to our system. The object was dubbed J1023+0038, and its source caught astronomers' eye as recently as at the beginning of the 21st century. However, its passes reached the Earth only in 2017. This was the first ever millisecond optical pulsar to be discovered. In essence, such celestial bodies are neutron stars as well. With a rotation period ranging from 1 to 10 milliseconds, the spin rate of these pulsars is several times that of regular pulsars. They form part of binary systems, and their spin rate increases to incredible speeds as the direct result of the pulsar pulling material from the gaseous disk produced by its companion star of a smaller mass. It should be noted that when a neutron star is in its active accretion phase, we see it as a source of X-rays. When the rate at which it pulls the material drops, bright pulsed radiation can be seen in the radio and gamma spectra. To date, a few more pulsars of this transitional kind are known to science, which fluctuate between the X-ray and radio spectra in a similar manner. However, it was the first ever transitional optical pulsar with a spin rate of this intensity discovered by scientists. The rotation period of J1023+0038 is 1.69 milliseconds, which is 0.00169 of a second. The object itself is 4,500 light-years away from us. The mass of its companion star is 0.2 that of the Sun. It takes the pulsar 4.45 hours to orbit its companion star once. To date, the properties of J1023+0038 have not been investigated in detail, although it is likely to be a not very massive neutron star. Although the object was initially considered to be a radio pulsar, in 2013 scientists noticed that its impulses regularly subsided and it was known to flare up in the X-ray spectrum. According to scientists, this phenomenon may be accounted for by the fact that the pulsar was at the moment in between the phases, which looks like the following. Radio emissions occur when material from the companion star is pulled to the pulsar, but star wind does not allow material to form an accretion disk. That is why the gas cannot heat up much and looks brighter in the radio spectrum. In the second phase, the stream of material from the companion of J1023+0038 gets stronger and forms an accretion disk around the pulsar. The disk is in fact the source of observable X-ray emissions. It wasn't long before millisecond pulsating was detected in the optical band of J1023+0038. As testified by earlier observations carried out with the help of the Swift X-ray telescope, the neutron star was surrounded by an accretion disk at the time. According to those in charge of the studies, the pulsar may have started to flare up in the optical band due to electrons in its magnetosphere when these electrons' speed was close to the speed of light. In the future, astrophysicists plan to conduct additional observations to study processes taking place within this binary system. And now to the object of the kind located furthest away from us that is known to science. It is NGC 5907X1, a celestial body which is also the brightest of all pulsars discovered by now. Spotted in 2017, this pulsar is an ultra-bright X-ray source. Shockingly, it releases as much energy in one rotation period as the Sun produces in 3.5 years. Earlier, astrophysicists believed these ultra-bright X-ray sources to be black holes. However, after the discovery of NGC 5907X1, it became known that they may turn out to be pulsars too. The object is located approximately 50 million light-years away from our Sun. As for its spin rate, it is variable. For example, in 2003, the rotation period of the pulsar was 1.43 seconds, whereas in 2014 it dropped to 1.13 seconds. Just to compare, if our Earth were to be able to change its rotation speed in the same manner, a day on our planet would last just 19 hours. Modern astrophysical models cannot account for the intense luminosity of NGC 5907X1, although scientists believe it to have something to do with a powerful multipolar magnetic field that may be concealed within the pulsar. It will take even more complex studies to find out the reason for the emission of such staggering amounts of energy. It goes without saying that to detect a celestial object that absorbs all light shed on it is a challenging task, to say the least. That is why there are not that many confirmed black hole candidates today. Still, mathematical modeling shows that their number in our galaxy may reach 100 million. This may seem an incredibly big number, but since there are 200 to 400 billion stars in the Milky Way, it makes us realize that in all these expanses, black holes are objects one doesn't come across that much. In one of our previous videos on the topic, we mentioned that a star, the progenitor of a black hole, has to have a mass of at least 18 to 20 solar masses. Only this will ensure a powerful enough supernova to compress the scorching hot core of the star to an exceptionally dense clump of material. After this has occurred, nothing will be able to stand up to the object's gravity force and escape beyond the boundaries of a conventional sphere predefined by the so-called Schwarzschild radius. What used to be a star transforms into a bizarre object with an inner makeup that would defy description by the physical laws we're familiar with. The object, referred to as A0620-00 or V616, is one of the black holes closest to our Earth that we know of. It lies 3,300 light-years away from our planet and forms part of a binary star in the constellation Monoceros. The other object in the system is an orange dwarf with a mass half that of the Sun. Every 7.75 hours, it completes a full orbit around an invisible object of unknown nature. Estimates show the mass of this invisible object to be around 6.6 times that of the Sun. It is admittedly too much for a neutron star. This leads one to believe that the bizarre invisible object is more likely than not a black hole. In addition to getting deformed and elongated by the more massive neighbor's gravity, the orange dwarf is also getting stripped of the outer layers of stellar matter. Spiraling streams of scorching gas gradually flow to the black hole and form a bright accretion disk. It is thanks to this dazzling disk that the black hole was detected. There are at least several dozen stars in the environs of V616, some of which almost certainly have their own planetary systems. It is highly likely that in the future, one of these stars will get dangerously close to the black hole and as a result will be sucked in by the object's insane gravity. This unfortunate star will have no choice, and in this case, the same slow demise is eventually awaiting the black hole's new companion as that of its current one. The process of interaction of a black hole with other objects largely depends on their mass ratio. The smaller the distance between them and the more massive the black hole, the stronger the influence of its tidal forces over its companion. The star may be deformed by them and get stretched towards the system's common mass center. They can also form channels that would carry stellar matter closer to the black hole, adding up to its accretion disk. If the tidal forces happen to be strong enough, they may well destroy the object that is being sucked in by turning it into a fiery ring. It is assumed that there may be planets orbiting a black hole, just as if it were a regular star. In contrast to a widespread opinion, black holes are actually not able to suck in all objects around them indiscriminately. From the point of view of gravitation, in astronomical terms they behave just like any star with the same mass. That is why, incredibly though it may seem, a black hole may well have a stable planetary system. There are several ways for them to form. Firstly, new celestial objects may originate in a nebula of gas and dust that is formed after a supernova. Influenced by gravitation, they first form clumps of material that collide with each other and attract cosmic dust. As a result, they eventually turn into planets and satellites, as well as large numbers of small celestial objects, like asteroids and comets. The radiation of the black hole's accretion disk may be powerful enough to warm them, and even melt ice on their surfaces. Hypothetically, a planetary system like that could be favorable enough for life to originate and, with any luck, evolve. Secondly, when a black hole captures and destroys another planetary system, some of its objects may choose to take up stable orbital positions around their new host. Of course, this makeover would bring about dramatic changes on the celestial object's surfaces. Thus, an ice giant may transform into an ocean planet, and a gas giant may lose almost all of its hydrogen and turn into a Chthonian planet. Thirdly, space wanderers like rogue planets or interstellar asteroids may also be ensnared by the massive object's gravity. Even though systems like that have not yet been discovered in practice, there is no reason to suppose they are non-existent. If, on the other hand, a planet is too close to the system's center, and the black hole is massive enough, other factors come into play. A scorching hot stream of material forming the accretion disk will strip the celestial object of its atmosphere, and its friction will slow it down and pull it still closer to the black hole. Eventually, extremely powerful tidal forces will rip the planet to tiny shreds. The debris will be pulled into the accretion disk and gradually melt in the hot gas around. In the end, they will inevitably get swallowed up by the black hole and, in essence, become part of it. It is posited that there are three main types of black holes to be found in the universe that are different first and foremost in terms of their mass. The first type can be found in the center of most spiral galaxies. These are gargantuan black holes with masses reaching several billion solar masses. The density of matter in the central part of a galaxy is generally extremely high, which is the reason why there originates a big number of large and bright stars quite closely packed. As they rapidly burn out, they transform into black holes, which in their turn rapidly grow and often merge with each other. As a result, supermassive objects are born, which are surrounded with giant accretion disks made of scorching hot material. They illumine space so brightly that it makes them seen from billions of light years away, even if their galaxy is completely unobservable to us. These objects are known as quasars. The second type is much more widespread, but at the same time, black holes like these are not that easily detectable. Their masses are close to those of stars, and they form out of large stars at the end of the latter's life cycle. By devouring other celestial bodies and interstellar gas, these objects gradually gain in size and eventually turn into intermediate mass black holes. They can also merge together, which generates gravity waves that distort space many light years around. The third type is the hypothetical primary black holes. Their existence has been inferred from today's theory of universe's origins and evolution. Fluctuations in matter that filled space in its early stages of evolution may have been favorable for black holes of infinitely small size to originate. It should be mentioned that according to estimates, the smaller an object of this type, the faster it evaporates, and at the end of its life cycle it turns into a tremendously powerful electromagnetic impulse. Modeling shows that primary black holes with masses around 10 to the power of 12 kilograms are supposed to be flaring up sometime around now, but to date, no such event has been registered yet. According to a certain hypothesis, a microscopic black hole may form on collision of extra high-energy elementary particles. This variety is referred to as quantum black holes. Still, the conditions necessary for such an event to happen are impossible to be reproduced in lab conditions, and estimated life expectancy of these hypothetical objects is so small that it can hardly be measured with today's latest and most advanced methods. That is why quantum black holes still officially exist only in theory. Of course, it is extremely difficult to detect such dark and compact objects. Some of them happen to have a star companion, whose anomalous trajectory of movement gives telltale prompts of there being an invisible thing in close proximity. Another popular method of detection is observation of accretion disks. These object spectra have some typical features that allow telling them from other sources of light in space. Sometimes we're lucky enough to get a snapshot of a disk with a black spot in it that is evidence that the observed object's structure is quite unusual. A black hole may also be detected thanks to the gravitational microlensing effect. This involves detecting the massive invisible object as it transits between the Earth and a remote star. This changes the star's spectrum in a special way. But admittedly, this method requires a number of rare factors to successfully work. Distances from the Milky Way to other galaxies are by all accounts mind-boggling. As a rule, it is anything from millions to billions of light-years. Due to the universe's cosmological expansion, the distance between the Earth and any remote object in the universe is constantly growing, which makes the light emanating from this object look redder than it actually is. This phenomenon is known as a redshift. It is of great help in gauging distances and velocities on the astronomical scale. Alternatively, some galaxies' spectrum is blue-shifted, which means that they're not on an escape trajectory from us, but on the contrary are moving to meet us. One of these unusual space objects is the galaxy M86 in the Virgo cluster. Roughly 52 million light-years away from the Sun, it is moving towards the Milky Way at a speed of around 244 km per second, which makes it one of the fastest-moving blue-shifted galaxies. By moving at a high speed through the scattered gas the Virgo cluster is filled with, M86 is constantly shedding its own interstellar matter. As a result of this process, it leaves a trail of long lines of warm ionized hydrogen behind. M86 is connected with the almost destroyed spiral galaxy NGC 4438 with several of these filaments. These two galaxies are thought to have collided at some point in the distant past, which was the smaller one's undoing. Interestingly, M86 is known to have destroyed its other neighbors in the past as well. Several stellar streams have been detected in its halo that are likely to be the remains of smaller galaxies absorbed earlier. An impressive number of globular clusters in its structure is another outstanding feature of M86. Observations show that their number is upwards of 3,800, which is around 25 times as many as in the Milky Way. There is a theory that claims these clusters to be the remains of dwarf galaxies that M86 would have absorbed in the past. If it really is the case, then it would have destroyed tens or even hundreds of other galaxies. Having said that, M86 looks anything but unique. The galaxy ESO 137-001, which we'll be looking at next, has a similar shape. But unlike M86, it appears more outlandishly original. Located 227 million light-years away from the Sun, it is as heavy as 5 to 14 billion solar masses. As for its stars, most of them are young and bright blue giants. ESO 137-001 in its turn is part of Abell 3627, a large galaxy cluster. Moving to its center at an incredible speed of almost 2,000 km per second, the galaxy collides with interstellar gas pressure inside the cluster. As a result, its own gas is blown out, leaving behind tails that stretch for up to 260,000 light-years. Incidentally, the mass of interstellar gas in those areas is 2 to 4 times that of the gas inside the galaxy. It is hardly surprising that starbursts are a common thing here. That is, stars don't stop forming in these enormous streams made up mostly of hydrogen. When seen from the side, ESO 137-001 appears like a giant jellyfish floating through endless expanses of space. Unfortunately, as the galaxy is continuously stripped of its interstellar gas, its life expectancy diminishes too. With not much material left, no new stars can form here. which greatly affects the structure of the spiral arms and central bulge of the galaxy. On the bright side, scientists have a chance of finding out more about dark matter and its interaction with other space objects by observing the behavior of the gas streams left in the galaxy's wake. Speaking about the formation of new stars, there is a galaxy with a name that speaks for itself: Baby Boom. Around 4,000 stars are born here every year, which is about 400 times more than in the Milky Way. Straightforward calculations show that on average, a new star lights up in this area of space every 2 hours. The Baby Boom galaxy lies around 12.2 billion light-years away from the Earth. This means that what we see when observing it is what was happening just 1.5 billion years after the hypothetical Big Bang. It was a time when the universe was still in the process of forming its structure. What is taking place in the galaxy now is drastically different from what we expect to observe there in theory, based on what we know about star formation. The reasons why stars are produced here at such an astounding rate are not known yet, but it is beyond any doubt that Baby Boom is able to provide us with a lot of information about the early stages of our universe's evolution. One of the few galaxies one can observe through an amateur telescope is the so-called Sombrero Galaxy, official designation M104. It lies 30 million light-years away from the Sun, and its diameter is roughly 4 times smaller than that of the Milky Way. The Sombrero Galaxy's outstanding feature is a massive ring of dust and cold hydrogen enveloping it. Observations show that it is here that most young stars are born. In addition to the peculiar ring, the Sombrero Galaxy is also remarkable for its elaborate inner makeup. Observations with the Spitzer Space Telescope show that most stars in this galaxy form a structure typical of elliptical galaxies. The stars here are mostly rather old yellow and red dwarfs. The other stars here, on the other hand, form spiral structures concealed within an elliptical cloud. It is thought that this phenomenon is a result of two galaxies' collision, with their stars subsequently and almost inevitably mingling together. It is incredible that the galactic structures survived a merge of that scale with minimal damage, are none the worse for this tremendous collision, and can still be observed. Another peculiar feature in the Sombrero Galaxy is exceptionally powerful X-ray radiation emanating from the center. It is assumed that the accretion disk of a supermassive black hole may be its source. The mass of the hole is estimated to be over 1 billion solar masses, which makes this enormous object one of the most massive black holes known to science today. There are also several sources of tremendously high frequency or terahertz radiation detected within the galaxy, although today their nature is still a mystery. Our galactic parade today is concluded with yet another object boasting an elaborate inner structure, the eerie M64 galaxy, rather aptly dubbed the Black Eye Galaxy. The nickname comes from a dark band of cosmic dust that partly conceals the galaxy's center from the observer on the Earth. Due to this line of cosmic dust, as well as the exceptionally bright active nucleus, it is impossible to estimate the Black Eye's number of stars even roughly. What we do know is that it is comparatively small and not so remote. Its radius measures 25,000 light-years, and it lies approximately 17 million light-years away from the Milky Way. The Black Eye Galaxy is made up of two well-defined parts. Interestingly, the inner disk with a bulge rotates in the direction opposite to that of the outer ring. The most likely explanation for such a bizarre makeup is that the galaxy formed after two smaller ones collided and merged in the distant past. Admittedly, it would take a combination of a number of mutually independent factors for such a fascinating and well-defined structure to form. For example, the progenitor galaxies would have moved at specific velocities and come together at a certain angle. The odds of a success would have been minuscule. In terms of the vastness of the cosmos, our planet is just a small rocky fragment, traveling at incredible speed through boundless emptiness. For billions of years, it has been orbiting the Sun, maintaining a distance of about 150 million kilometers. However, the true size of our system is much larger. According to modern concepts, its outer boundary, which is considered the far edge of the hypothetical Oort cloud, is at a distance of about 100,000 astronomical units. Beyond this boundary begins the vast abyss of the interstellar vacuum, space so rarefied that there is on average only a single hydrogen atom per cubic centimeter. The distances between the nearest stars in our part of the galaxy are a matter of a few light years, and a photon that has left the Sun can reach Proxima Centauri without ever colliding with a particle of matter. This vast void is a pervasive and integral part of the deep structure of the cosmos. It permeates the entire Milky Way, separating stars and planets, black holes and white dwarfs, super-dense pulsars and scattered nebulae. If you move outside the galaxy, you can see that it is surrounded by an even deeper vacuum. For example, between us and the Andromeda galaxy lies 2.5 million light-years of exceptionally rarefied space. This distance is so great that 25 galaxies like ours could fit in it, yet it is filled only with the deepest cosmic vacuum. And this is only a small part of the great cosmic abyss. The Milky Way, the Andromeda Nebula and the Triangulum Galaxy, as well as about 100 of their satellites, are bound together by pervasive invisible threads of gravity. This structure is called the local group and is a large cluster of cosmic matter about 10 million light-years in diameter. The local group, in its turn, is part of an even larger formation, but a relatively small galactic filament by the standards of the universe, called the local sheet. This flattened structure, consisting of several hundred galaxies, has a diameter of about 46 million light-years, and its thickness is roughly 5 million light-years. The sheet is also part of an even larger association called the Virgo supercluster. However, very close to the local sheet, outer space suddenly changes its appearance. Here, the usual colorful universe is harassed by a giant black abyss known as the local void. In fact, the local sheet is one of its walls, the other conventional boundaries being the Perseus-Pisces supercluster and the Pavo-Indus supercluster. At the same time, the void is divided into conventional parts by several rarefied galactic filaments, and wide passages link it into a single network with the neighboring Sculptor and Hercules voids. Due to the cosmological expansion of the universe and the gravitational influence of the surrounding matter, the volume of the local void is slowly increasing. At present, its diameter is about 150 million light-years, and the distance to the center is at least 70 million light-years. Meanwhile, the nearest edge of this cosmic void is located very close to the Earth, at a distance of about 3.2 million light-years. Due to this proximity, the local void occupies a significant part of our planet's night sky, about 40%. The main plane of the Milky Way, containing many bright stars and large nebulae, covers the central part of this region from us. Still, its edges do remain accessible for observation. In 1854, a dwarf spiral galaxy was discovered a little north of the constellation Hercules. It was dubbed NGC 6503. Later, with the advancement of observation techniques, it became known that it is located in the middle of the local void, and its distinguishing feature is the incredible multicolor appearance. The spiral arms of the galaxy are permeated with bright red clots of heated hydrogen, and shining blue nebulae are stellar nurseries. The center is obscured by clouds of cool gas and dust, which have a noble brown color. NGC 6503 has a diameter of about 30,000 light-years, and its distance from Earth reaches 17 million light-years. Due to the gravitational pull of the Virgo supercluster, this galaxy is approaching us at a speed of about 43 kilometers per second. It is believed that its gradual approach to the local sheet will eventually saturate its space with interstellar hydrogen, causing an increase in star formation. It is estimated that in a few billion years' time, the current number of young stars could double, and the small galaxy will shine with renewed vigor. The motion of NGC 6503 is a clear demonstration of how the voids are likely to have come about. It is believed that the foundations of the large-scale structure of the universe were laid in the first minutes of its existence, at the time of chaotic mixing of matter and energy. Cosmic cataclysms of incredible power shook the young universe, forming local compactions and voids. Subsequently, clots of matter became proto-galactic clouds, and areas of space of reduced density became voids. Over time, the pervasive influence of gravity intensified this contrast, pulling stars and cosmic gas into relatively dense clusters, making the space and voids even more rarefied. Observations show that the vast majority of galaxies formed between 10 and 13 billion years ago. In addition, no significant differences have been found to exist between the age of galaxies located in voids and those that form global filaments. This fact also confirms the modern theory of the formation of the large-scale structure of the universe. Meanwhile, allowing for the cosmological expansion of space, we can assume that with time, the local void will become larger and more rarefied, and the Virgo supercluster will gradually disintegrate into several independent groups. At present, it is an association of about 30,000 galaxies concentrated in a region of space with a diameter of about 200 million light-years. At the same time, the total mass of the cluster is about 1.5 quadrillion solar masses, which is tantamount to about 1,000 galaxies such as the Milky Way. The Virgo supercluster is partially contiguous with two other galactic superclusters, the Centaurus and Pavo-Indus superclusters. At the same time, its other side borders on a vast region almost devoid of matter. It is called the Taurus void and is one of the largest known cosmic voids. It is rather difficult to study this part of outer space. The reason is that most of the void lies in the so-called zone of avoidance, a sector closed off from us by the Milky Way plane. The bright stars in our galaxy outshine the fainter and more distant sources, and interstellar matter absorbs and scatters their light. However, thanks to infrared studies, we do have some ideas about the structure of this void. The diameter of this tremendous void is about 200 million light-years, and the distance to the center is about 150 million light-years. When observing the void, one is immediately struck by the remarkably clear boundary between the relatively empty space and a bright cluster of galaxies located much further away. It is called the Perseus-Pisces supercluster and is one of the largest in this part of the universe. A transition this sharp is characteristic of dust clouds, even though infrared studies do not confirm their presence. In all probability, the clear boundary between the void and the supercluster is caused by gravitation, but the exact mechanism of their action still remains to be found out. Meanwhile, it is thought that the Taurus void, like most other cosmic voids, is not quite as empty as one might imagine. The way light passing through it is distorted suggests that this region may hide in its depths giant gas and dust clouds, the cradles of future galaxies. According to other hypotheses, huge masses of dark matter, the most mysterious substance in the universe, the properties of which are still not fully understood, may be contained inside the void. According to the most daring ideas, there are clots of antimatter or even more exotic matter with negative mass in the centers of cosmic voids. Nevertheless, despite their boldness, these hypotheses lie outside the boundaries of generally accepted scientific concepts, which makes it difficult to verify them experimentally. Currently, only 2 separate galaxies have been discovered tucked away in the space of the giant void. One of them, UGC 2627, has a spiral structure and resembles the Milky Way. while the second, known as UGC 2629, is an elliptical dwarf galaxy. Both objects are located almost in the heart of the void, at a distance of about 185 million light-years from us. The distance between them is small and is within a few 100,000 light-years. Perhaps there are other single galaxies hiding in the space there, but the Milky Way disk does not allow us to see them. Meanwhile, the Virgo supercluster, together with 4 other superclusters, forms a giant galactic filament called Laniakea. It contains more than 100,000 galaxies and stretches for more than 500 million light-years in space. Its gravitational center is the Great Attractor, a mysterious supercluster of galaxies located 250 million light-years from Earth. In its turn, Laniakea is part of a vast galactic stream, and further out, one can see that most of it is surrounded by a black abyss of unprecedented proportions. The light of distant galaxies is drowned in its emptiness, and even the mysterious and elusive neutrinos take billions of years to cross this cosmic abyss. To be honest, it is hard to believe that despite all the development of observational technology, such a gigantic void was noticed only 10 years ago. The year 2013. The University of Wisconsin-Madison. A team of astronomers led by Professor Amy Barger is working to determine the distance between galaxies. In the process, an unexpected and staggering fact is discovered. It turns out that Laniakea and most of its surrounding superclusters are enveloped by a cosmic void of unprecedented proportions. After making calculations, scientists discovered that its diameter exceeds that of any previously known void. The size of the discovered void turned out to be so enormous that several fundamental cosmological principles were questioned. It appears that the universe is much more elaborate than we imagined. The research done by Amy J. Barger, Ryan Keenan and Lennox Coey has led, in all likelihood, to one of the greatest astronomical discoveries of recent years. Their work has shown that our galaxy, along with its surroundings, is located in the middle of the largest supervoid known to science. It was named KBC, after the first letters of the discoverers' names. Observations show that the shape of the giant void is close to spherical, and its diameter may exceed 2 billion light-years. According to calculations, the Milky Way is located a few 100 million light-years from the conditional center of the Great Cosmic Abyss, and about the same distance from its edge. The discovery of a giant bubble of emptiness surrounding Laniakea helped to explain the paradox that had kept scientists busy for many years. The fact is that all galaxies in the universe are gradually floating apart due to cosmological expansion. Measuring the speed of this motion allows us to calculate the so-called Hubble constant, a fundamental physical constant characterizing the rate of expansion of space. However, if we take the galaxies closest to us to calculate the Hubble constant, it turns out that the rest of the universe is expanding too slowly. On the other hand, if we take distant objects as the basis, the Milky Way's surroundings are moving faster than they should. The discovery of the void has accounted for a lot. The fact is that the galaxies inside it, including the Milky Way and its neighbors, are constantly experiencing additional gravitational influence from objects outside the void. This creates an additional force that gradually stretches our cluster in different directions. It is also surprising that the KBC void is so huge that it comprises not only superclusters of galaxies, but also other voids. For example, the local void, as well as the torus void, are part of its structure. It turns out that compared to other voids, even though KBC looks large, it isn't quite so empty. Nevertheless, according to calculations, even this void is just a barely noticeable dark spot against the background of the observable part of the universe, the diameter of the latter reaching 92 billion light-years. If we look at the global map of the universe, we will see a lot of dark spots on it, close to the KBC void in terms of their size. Most of them easily fit within the framework of modern physical theories, while others show surprising and strange properties, difficult to explain from the point of view of science. And one of the most noticeable riddles of this kind in space is the Eridanus supervoid, also known as the CMB cold spot. It is estimated to have a diameter of 500 million to 1 billion light-years, and it lies at a distance of between 6 and 10 billion light-years from the Milky Way. This means that this formation is one of the most extensive elements of the large-scale structure of the universe. The void is located in the southern hemisphere of the Earth's sky and occupies an impressive area on it, several times larger than the full moon. However, it is impossible to see it with the naked eye. The CMB cold spot is visible only with the help of special telescopes that study the cosmos in the microwave spectrum. Thanks to these, astronomers have discovered that within the spot, relic CMB radiation of the universe is about 70 microkelvin colder than the metagalactic average. This deviation is nearly 4 times as intensive as the strongest anomaly previously recorded, and its gigantic size makes it a truly enigmatic object that requires extensive study. It is now believed that relic CMB radiation traveling through hundreds of millions of light-years of deep vacuum is gravitationally influenced by distant galactic superclusters. This causes the pervasive echo of the Big Bang to lose energy, making the CMB cold spot appear cooler in images than its surroundings. Nevertheless, this effect cannot fully explain the excessive cooling of relic radiation. According to calculations, the attraction of external galaxies can account for only a quarter of the observed deviation. It is assumed that the remaining 75% of the effect may be due to the impact of hypothetical dark matter or dark energy concentrated in the depths of the void. However, it is going to take a while before we can truly unravel this cosmic mystery. Despite significant advances in astronomy and space science in recent decades, much of the universe remains beyond our comprehension. As the epitome of the unknown, outer space represents a fundamental challenge to our minds and technological capabilities. To overcome these limits and to expand human cognition, new research is called for. For only then can we understand the meaning of our existence and our place in the universe. And let's keep in touch.